Good morning, my YouTube viewers. It is Crystal here, and I just wanted to do another code review for you. And this code review is going to be how to do a classification and prediction in 12 lines of code. Okay, so basically the secret to getting all of the code into 12 lines is the semicolon, because the semicolon allows you to put more line of code on one line in your Jupyter notebook. So we created this program in Google Colab, which is a free online Jupyter notebook sponsored by Google. And so what we'll do is we'll go ahead and do the code review. So on line number 1 of our classification and prediction, we import all of our libraries. So we're going to import NumPy as NP, which is a numerical computation library. We're going to import Pandas as PD, as a data frame creation and manipulation library. We're going to import matplotlib.pyplot as PLT as your graphics library. We're going to import Seaborn as SNS as another graphics library built on top of matplotlib that also has some data sets that we can use to practice on. We're going to import sklearn, which is Python's machine learning library. And in that machine learning library, we've got at least 3 functions that we are going to be using in this classification. So that's line 1. In line 2, we're going to load the data set. So data equals sns.load dataset, penguins, cache equals true, data home equals none. And what that does is that loads up the data set that we've got from Seaborn to practice on. And then data equals data.drop in A. What that does is that deletes all of the, or that drops all of the rows that have not applicable values in them. So you're going to have less rows than you started out with, because all the rows that have a non-applicable value are going to be removed from the data set. And then semicolon, and then we have data, and then data shows the actual data set. So this is the actual data set after we have dropped the rows. So approximately 11 rows have been dropped, because we have 343 rows at the end, and we have only 333 rows total, so that means they've dropped approximately 11 rows. So after that, that's line 2, so we're going to go to line 3. Line 3, what we're going to do is we're going to create a hisplot of the 2 variables, male and female. So sns.hisplot brackets data.sex. So what this penguin dataset does is it gives you the size of the island that the penguin was found on, the species of the penguin size, and it says whether it's a male or a female. So when we go to the hisplot, we have 2 classifications, being either male or female. So strictly speaking, you didn't need to have the hisplot. You could have had, you didn't have to include it, but I decided to go ahead and include it because you need to know how many classes you're going to have in your target variable. So that was line 3. So line 4, 5, 6, we're going to encode all of the object columns. So for column in data, if data square brackets call square brackets dot dtype equals object, data square brackets call square brackets equals ordinal encoder dot fit underscore transform brackets data square brackets call dot values dot reshape brackets -1 comma 1 brackets. So what we've done is all of the columns that are strings are going to be converted to numbers, because the computer needs to see numbers in order to make computations. So that was lines 4, 5, and 6. So 7, 8, 9, what we're going to do is we're going to define our training and validation sets. So line number 7, you're going to define your training set, which they're going to take a random sample of the data file and take 90% of that random sample, and that's going to be your train file. And the validation set, you're going to take the data file and you're going to drop all of the train indexes. So the validation file is going to be what's remaining from the train file, and it will be 10% of the total of the total data file. So your train data set will be 90% of data, and your val data set will be 10% of data. And that was 7. And then so line number 8, what we're going to do is we're going to define our X train, Y train variables. So your Y train is the sex column in train, and your X train is you drop the sex column from train and you use all of that. And line number 9 is exactly the same format, except that instead of doing it on the train file, you're going to do it on the val file. So Y val is the sex column in the val data set or data frame, and the X val is the sex column dropped from it. So that was line number 9. Okay, so line number 10 and 11, what we're going to do is we're going to define the model, and we're going to make predictions on it. So we'll just do this here. So just to make it a little bit easier to understand. The model is going to be extra trees classifier, because I've had really good results with extra tree classifier, so I decided to use that. In estimators is 100. Random state is 42. Random state can be any number. I just chose 42. And then we're going to fit the X train and Y train into the model, and then we're going to print out the score, and we got 100%. And then on line number 11, what we're going to do is we're going to define the variable Y pred, and we're going to do that by making a prediction on X val. And then when we print the score of X val, Y val, it's 100% as well. So we did really well on the extra trees classifier. And the last line, line number 12, what we want to do is we want to check the goodness of fit. So we're going to call up our confusion matrix, and then we're going to call up the classification report. So when we call up the confusion matrix, we had 100% accuracy. You had 17 zeros, and so you have 17 true positives and 0 false negatives. And we had 16 ones And so we had 16 true negatives and 0 false positives. And then we're going to call up the classification report, and the classification report just gives you information about the classifier. So it gives you precision, recall, F1 score, and support. So we got 100% accuracy on that. And I'm going to be doing a blog post on this, and then whenever I do a blog post on it, I'm going to go into detail of the classification report and explain it in detail, because the classification report tells you how well your classifier has performed. And in this particular instance, the classification report, the classifier performed very well, because the classification report gave you 100%, which is what it wanted to see. So I'm going to go ahead and conclude this video because I've discussed all 12 lines of code, which is what I wanted to do. So I would like to thank my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you for watching my video, and I look forward to making more code reviews for you in the future. I'll put it on this side.